we should be live. I'm going to wait a couple minutes or a minute while people kind of join in. And I know there's a little bit of a buffer time usually of like when we go live versus when it actually shows up on YouTube and LinkedIn where we're streaming today.
Okay.
Sorry, go ahead.
No, go ahead.
As people are joining in, say hello in the chat. It's always really fun to see kind of like who's watching. Maybe also put where you're watching from. So I'm streaming from Seattle. Cam, I think you are too.
Yep, back home in Seattle.
We were just saying we're really enjoying the Seattle summer. If anyone else is tuning in from Seattle, you'll get what we mean. It's been great. And I just said the other day that I was like, I feel like I haven't been cold in a long time.
The last time I was really cold was actually when I went back to Austin for a few months ago. It's because the air. I always forget everyone just blasts aircon in the South.
Oh yeah. I lived in Florida for quite some time, and you're kind of going from one AC box to like another AC box most of the time, unless you're out enjoying the weather. But again, while people join in, feel free to say hello in the chat, where you're watching from. Also, maybe a little bit about why you're interested in AI observability, and if you want to mention about anything that you're building or questions you have, put them in the chat. I'm going to be going through talking with Cam here, and if any questions come up in the chat that are relevant, we can also potentially answer those if we have time as well. So with that, I'll go ahead and kick us off. Welcome, everyone. So my name is Sage Elliott. I'll be the host for today's fireside chat. At Union, we build tools around ML orchestration and making data and AI pipelines more robust and trusted. A lot of people know us from our open source work on Flyte, spelled Flyte. There should be links to that in the description as well, which is an AI orchestration platform, and Pandera, which is a kind of data quality checking tool. You can check out everything else we're doing at Union.ai. And we just launched a serverless version of Union if you want to quickly try out the tool. It's really cool and easy to sign up. There's no card or anything required. You get like $30 of credit. But today's chat is not about us. We have Cam with us from Arize. Welcome, Cam. How's it going?
Thank you. Thank you for having me.
And today's fireside chat is going to be on another important topic for, I think, really any pipeline, but especially specifically around LLMs today. But we're going to be talking around AI observability for LLMs with Cam from Arize. Before we go into the topic, could you provide maybe a quick introduction and let us know a little bit about your background and maybe a little bit about currently what you're working on, even though I'm sure we'll also dive way deeper into that later as well.
Yeah, happy to. So I joined early on, right after we kind of exited our original funding almost 3 years ago now. So been working with and collaborating with a lot of kind of strategic customers and partners across, of course, providing observability for their AI and ML applications and use cases. We can kind of dive in from there.
Awesome. Yeah. And I shared a link in the chat to Arize for people to check it out. I think it should also be linked in the description as well. So if you're watching this as a recording, I know a lot of people tune in kind of after it's been live. So go check out all the relevant links in the description. And so our main topic today is AI observability for LLMs. But before we get into maybe the specific part for large language models, could we talk a little bit about what AI observability is in general?
Yeah. So conceptually, right, like observability are kind of two components, if you will. One is the automatic evaluation and alerting. So instead of kind of needing to sit at a dashboard, check something periodically, you have that automated. And then the second part is you're kind of getting and monitoring on particular top line metrics, but really everything's not performing at the same level, right? Like there's going to be kind of cohorts, pockets, segments, however you want to kind of term them. Those are really going to be either outperforming or underperforming. And really what we want to do is provide the tooling, the workflows to help you figure out exactly why and what particular segments and pockets you should actually identify and focus on your troubleshooting, whether that's retraining, labeling some data sets to help that with that retraining or fine-tuning run. So overall, helping you kind of think through the big swath of an ocean of data and actually zoom in on what's meaningful and impactful there.
Right. Like someone might have a model in production, and if you're new to shipping models into production, it's not, you don't just ship it once and then you're done. It's often a whole kind of life cycle that you have around your machine learning model, and a big part of that is AI observability or ML monitoring, looking at the performance of a model in production, but also the data going into that model could be a really good signal as well. And so, like you had mentioned, you might find cohorts or batches of data that maybe look very different than, let's say, your training data set, for an example. And you might want to kick off some sort of annotation job saying, hey, there's new variations of data. We found them. It doesn't look like the other data we've seen before. Our model might not be performing as well on it either because it's never seen it before in the training data set. We will probably have a more robust model if we put this new data in, and then you can have people annotate that data, train a model, and then put it into production and kind of have that monitoring process over again.
Yeah, I think that's a really good point, because if you think about the alternative approaches, right, if you go through that iterative cycle, and a lot of customers of ours are either kind of retraining and kind of trying to reconfigure their models and release new candidates kind of blindly, either too frequently or not frequent enough, right? And there's going to be drawbacks to either approach. If you're too aggressive and you do it too frequently, you're just you're kind of sharing all these compute resources. Training a model is not just a flip a switch and it happens in 5 minutes. It's a very, very intensive process. And so if you do it too frequently, that means others on your team or other kind of business units are not able to utilize that compute. Or alternatively, then if you're not retraining enough or on the right data, then you're kind of just letting things kind of fester and have problems that are eventually going to blow up and become a lot bigger of a red alert. And hopefully with a solution like ours, we help you kind of figure those things out really, really quickly before it becomes a really big issue.
Yeah, it's interesting. Years ago, getting into machine learning, I feel like a common practice people would talk about is just at a certain time frame, like retrain a model, like every month. I'm making up a number, but they would just selectively come up with something like that. But that whole period between, your model could be performing very badly, which depending on your application is going to have different results. Like that could be a lot of money for you. It could be making poor decisions for users and they might not be liking your product, or hopefully it's not something in like healthcare or anything like that. And I think it's interesting seeing like the ML monitoring and AI observability being adopted way more, and it makes so much sense because just like you said, if it's a really good signal of how your model's performing and the data coming in, and then just kind of kicking off and maintaining that life cycle of like a reliable machine learning model in production. Oh, and like you mentioned, compute is a big thing, especially when it comes to like large language models. So if you're fine tuning Llama 3.1 or whatever, and you're just doing that every day versus maybe it's fine every month, and you can have some sort of monitoring solution to kind of let you know how it's performing, that can save you a ton of money and like engineering time as well. I think that's a really good point that you brought up as well. Now that we know a little bit about AI observability in general, and maybe a couple little use cases we sprinkled in there, tying this more in specifically with large how do we tie this in more specifically with large language models and developing, I guess, like LLM powered applications?
Yeah, I think there's lessons that you can always take and various approaches that are going to work, and then there's also going to be if you will, a paradigm shift, or to use a buzzword, or just different ways. It's not going to work the same, right? And I think the biggest one is going to be within predictive ML, whether it's a simple forecasting model and it's a regression or a classification, or even kind of legacy like BERT or the vision models. Generally, there is a very obvious and kind of easily accepted form of ground truth. The question is whether you get that ground truth back very quickly, or what's the latency, what's that kind of time horizon there. But fundamentally, if I predict that it's going to take 3 minutes for my Uber to show up, my ground truth is going to be when it shows up. Now, when you're kind of working within inherently all this unstructured data, this large amount of just text typically for large language models, or if you're kind of focusing and doing even image generation, what is a good response, right? That is a big package to kind of unbundle, right? Like a good response could be no hallucinations. It could also be kind of succinct and kind of a good summarization. It could be runnable code. It could be efficient code that you're requesting. It could be a cohesive query that you're searching back office databases for relevant information. So one, it's kind of a lot more qualitative, if you will. And so a big thing that folks need to kind of think about is like, what is that evaluation framework and how am I going to execute and utilize that? Then you can kind of lean on the original ML and AI kind of observability principles, which is let's take a statistical approach of, hey, like let's grab these kind of like everything that's flagged as a potential hallucination. Now let's try to understand what are the commonalities, what sort of things can be solved with different prompt iterations, potentially maybe different model configurations. Maybe I need to add in additional hops within an agentic workflow. But overall, like there's kind of some things that you can kind of pull through, and then there's going to be a few new concepts, if you will, that you need to kind of press reset. And the big one right now is evaluations and how do I even think about good or bad.
Yeah, it's if I'm sure most people listening or watching have used large language models before and know how ambiguous the input and output can be, and so it is a really hard problem to know exactly what is good or bad. And I know there's different like metrics that can give you signals around that. Do you have some kind of metrics or indicators that you like to start to use to measure the success of the large language models?
Yeah, I think one of them usually is hallucinations, or a second one is that can be quite interesting as we see these prompt templates kind of growing, right? And it's going to be interesting, I think, as we see how folks start iterating and adopting best practices on what prompt templates, what prompting techniques should we use. When are we kind of getting these diminishing returns on over explaining or overly being direct and repeating in the instructions, and all that could be kind of bundled into like an adherence evaluation. So that's an interesting one I like trying to start with folks, is just like, evaluate if this response is completely adhering to all the instructions, all the original kind of system prompting that you provided. And you'd actually be pretty surprised with like the small little ticks off that the eval will actually find. And so starting from there, then you're also needing to think about like the task at hand. And I think that's like where the kind of it can be freeing or a little like frustrating when you're kind of like going, well, what sort of eval should I have, right? And it really comes down to the task and the use case and what you're actually trying to ultimately build upon. And so those are the kind of the two ones I would start with, and then start thinking about what is my task and what would be good in that task. What am I trying to accomplish, and try to evaluate for that.
Right. Like if you're those are good general metrics to start with, but then let's say you're building a summarization app and you're typically taking in a large block of text or documents and then returning a smaller thing, and maybe you might even have specific instructions saying, make it this certain amount of text long. So you could say like, 500 characters or something like that. That could be a metric you're looking for. And then also out of that, maybe you're looking for something like a readability metric or something that you're trying to, like, you want this to be a very concise summary. So it's good to think about, just like with other machine learning applications, even though it feels a little more ambiguous, come up with what a good evaluation metric is for your specific task, and then kind of start from there is what it sounds like.
Yeah, and you kind of even gave examples. I don't know if it was intentional, but there's a big amount of focus and adoption on LLM as a judge, right? Like you're going to prompt and do some retroactive analysis on an LLM, another LLM call that's going to evaluate that particular task. But for your example of like a character count, right? Like that could just be done through code in a heuristic. And so you're going to want to use a combination of all these things, right? Like an LLM actually is not that great at counting characters anyways, so it's better to just write a little bit of code and use all those as combinations and signals to help you understand, one, like, is it following the rules, like character count, and then two, is it qualitatively executing well there.
And you mentioned LLM as a judge, which isn't something we specifically even talked about, but I think that's a really interesting concept of using LLMs to, basically help build better LLMs. And maybe we'll get more into this later too. But I think Arize has a feature, if I'm not wrong, about like a built-in LLM to the platform that I think kind of helps, find I don't know, potential ways to monitor better or what's going on, and provides recommendations?
Yeah, I like to think that we're early on in the pioneering of LLM as a judge, because the big question we're kind of thinking about, right, going back into how do I evaluate the swath of data, right? Like when you're early developing, the instinct and the right instinct, in my opinion, is the human label, right? Like whether that's yourself and it's a general task, and I as a human could tell the difference between a good and bad response, or we work with a lot of folks within the medical and healthcare space, and so they actually need a kind of engage with SMEs, whether that's doctors, researchers, et cetera, to kind of grade these responses. Again, like in early development and even kind of like getting a little bit more mature in the development, those folks can have the bandwidth to go good, bad, this is why. But then when you start going at scale, whether that's even internal testing or you have beta users or you actually are graduating into production, your scale is not going to be 5 samples or 50 samples. Your throughput might be 50 samples a second or a minute or an hour. That's going to become a lot more data. And whether you're the US government that we work with or large tech like Meta, you fundamentally do not have enough resources to throw at and human annotate everything. And so LLM as a judge has its inherent drawbacks, right? Like you're using a non-deterministic approach here, but you can mitigate that, right? Like that's the whole point of adopting all of this tech. And so it's a great kind of first pass, and it's a consistent framework that you can apply and have that kind of grading and scoring system so that you can actually utilize those valuable resources, which are the human capital, the annotators, and they can actually spend their time on edge cases, things to confirm that it's a hallucination, not 20 samples where they just spend maybe 20 minutes on, but they're just reconfirming very obvious scenarios that an LLM actually has been historically able to kind of suss out and say, those are good. So it's all about working efficiently with the kind of constraints of the most restricting thing ever, which is the human resources there.
Yeah, the amount of predictions that come through is insane sometimes, and so having a AI tool to help build better AI, I think, is really cool and probably the future. What it sounds like. Do you have any other use cases, like you mentioned healthcare? I think that was really cool hearing about. Do you have any other use cases you could share? Maybe like an example where the implementing AI observability significantly influenced the development, or it provided like a big improvement to a LLM application. And you don't have to mention any like company names or anything if it's not like a public thing.
Yeah, one of the early adopters, I would say, and it's interesting. We see to my mention of like healthcare and medicine. I'm actually surprised with how much to production, if you will, like it's actually interfacing. They've actually allowed folks to utilize and adopt LMs. You would think in a very regulated industry with very sensitive data, they'd be a little bit more tentative, but they found use cases that don't require PII or sensitive data and actually unlock it by kind of sifting through kind of studies and things like that. Another industry that we work a lot with is travel, and that's where like the best of both worlds is, in our opinion, is one, there's so much volume, right? Like most people love traveling. And so there's a high degree of like applicability and a large audience. There's a lot of variety. Like we probably have a lot of overlap between yourself and myself of what we like to do on vacation, but we probably also have a lot of individual interests, right? So that means there's going to be a lot of variance within the kind of things that the LLM application will have to take into account and actually work with. And as you develop, you kind of have to think about, am I building this that works well with families, but also business travelers, solo travelers, couples, just friend groups, etc. And so we worked with a large kind of travel technology organization, and they have a lot of reviews on their sites. And so what they did very naturally is like build in a trip planner, right? Like, hey, like I'm thinking about going to Madrid, or I'm going to London, or I'm going to New York. Like I'm going for 3 days, and here's all this. Like, what am I going to do? Like, where should I go stay? What should I go see? And so I think that's one of the most advanced use cases that we worked with, because what it's doing is it's taking in structured data because it's doing this intake. Another way you can interact with it is like pure NLP, where it's going to extract out kind of structured elements, right? Like who are you going with, what are the dates, what's your budget range, things like that. It's going to take that in account, and it's going to actually interact with kind of traditional ML models as well. So the LLM is actually not the one facilitating the hotel search, the attractions. Those are actually they're actually utilizing their existing infra to kind of bring together results. One, because that's going to be quicker than pinging out to OpenAI every time. It's their internal networking, and then two, it's going to be cheaper, right? They already built these models, and they don't have to pay any API credits. And then they can use the LLM to really lean on its strength, which is like personalization, generation of text. And so one of the things that we helped them with is one, are there any hallucinations within any of this kind of downstream? Is it making up, I said I was a solo traveler, and then 5 steps later, it said you and your partner. We want to catch those whether when that game of telephone almost comes up. But you also want to make sure it's not kind of creating hallucinations for things like, hey, like suggesting a bar and saying it's family friendly. We saw a few of those responses that we helped catch, and that actual chatbot's actually already live, and it's I would think it's improving every day as it's kind of being observed now.
That's awesome and a really cool use case. How do you help catch hallucinations specifically? Is that like a labeled kind of thing in Arize, or is it there's a metric that is used to kind of infer that it might be, and then it flags it?
Yeah, for us, I would say our hallucination definition's a little bit more specific than the general term. The general hallucination is just it's making up a fact. What we're really focused on is it making up a fact from any kind of context or reference, like reference context that's provided, and that means that we're not going to really catch is this Michael Jordan's birthday, and that's the wrong date. But what we will catch in that scenario is, hey, out of all these reviews, did it make up something that wasn't in that review, or in that summary that those studies that you provided to for a medical use case didn't make up anything within that summary. And so that's a lot more explicit of a check that an LLM can perform and check on. And so realistically, it's checking, did it kind of conflate anything from the provided context there.
Awesome. Really cool. And very important, I feel like, for for almost any LLM in production. And it's interesting how many people, I think this is changing, but when, like, let's say like a year ago or two, everyone was putting LLMs in production, and I'd ask, like, how are you monitoring them? Are you monitoring? And people would have to just kind of go,
that was the world that they were in, right? Like
right.
When GPT came out, or ChatGPT came out, everyone's just like, let's put our best people on the task. Let's create these tiger teams, within reason. Like, don't go like, I don't want to see $1 million on my desk. That's a bill, but like within reason, like don't worry about like budget. Like just build something cool, and we'll kind of figure out how we can operationalize that as a business. Now, kind of like I would say the adults are coming into the room and saying, what's our token usage? How do we charge these business units? Are like, do you really need this like 4.0, or could you actually get by with a Llama 3 that we then host, and it's going to be way cheaper? Like, there's all these more business focused. The accountants are coming in, and they're really making sure that you're actually getting a lift on these applications. And so it's really cool, because like these are new problems that organizations have to solve now. Is one, let's build something and make something stable and actually people want to use it, to now, like, is this even creating ROI? Is this actually useful in something that we should commit as a business to keep investing within? Not only just that use case, should we make it 5 more? Should we keep making this a priority and initiative, or is this kind of a passing fad? And so that kind of rigor now is becoming a lot more required and thought about across the kind of enterprises there.
I liked how you mentioned too, like switching potentially different, to a cheaper model like hosted, which is another thing ML monitoring can do a great job at helping with. Like if you have been using GPT API and then you're experimenting with a fine-tuned fee 3 with RAG, Maybe it's actually for your specific use case. You don't need that foundational model anymore that can answer any question, and your fine-tuned model can do just as good of a job, and it's way cheaper. You can have kind of both of those things running on production data, use something like Arize to see how they're both performing, and then maybe switch that cheaper model if it's performing better or just as good over time.
Yeah, one of the more interesting trends I'd also say is not only just like open source and larger models, which Llama 3 realistically is catching up with GPT, is there when you first built, like most people are making 1 to 2 kind of LLM calls. It's very monolithic. Now people are breaking that out into a very like similar to like microservices or agentic workflows where you're kind of breaking out all these tasks. You're using a lot of components, whether they're tool calls, function calls, or models. And then also people are now starting to think about, could I use a smaller, medium-sized model? And so not only is it, should I use this big model versus from OpenAI and Llama? It's like, well, what about this Mistral medium? Could that work? And could it work because it's a very, very specific task that it has to do?
Yeah, and someone in the chat, Charles said, "Yeah, switching models is scary. It feels
Yeah,
dangerous." And I think having tools like the monitoring helps you feel a lot safer, but you actually know that it how it's performing. And like I mentioned, you might even do a little transitional period where you're running both on production data, seeing that over time, putting that new one in, and it feels way less scary. Same with if you're doing a major refactor on like your prompt engineering too. That was another
yeah,
thing. People are changing prompts all the time, like the system prompt that how your model behaves. And that was another thing where I'd be like, oh, cool, like you changed it. How do you know it's better?
yeah.
And again, a lot of times you kind of get a shoulder shrug. Like they might test a couple things. Maybe they have a small little golden data set, but they don't really know over time. And to me, that feels scary too. That's kind of like changing your model.
Yeah, changing your model, changing your prompt. I would say that's like the theme that we're going through in the last like 2 months is the big every conversation I have is around prompt iteration. And more specifically, it's like I changed one thing and I checked these 5 samples and they look good. That was what I was focused on. But did I overfit essentially on that particular kind of problem I'm trying to solve, and did it actually regress on 20 more samples? And so what we release in both of our products, we have 2 solutions: Arize, kind of a traditional platform, as well as Phoenix, completely open source and free to use. It's a Python library. Both of those can facilitate experiments and run on data sets, right? Like best practices in science is keep everything constant and then change one thing. And so that's what those data sets and experiments allow you to do, is keep everything consistent, whether it's model configuration, model, prompt, and your data set. And now I might want to change one of those things. Usually you want to keep the data set the same so that when you run experiment 1 and run it on number 20, you use it the same on the same kind of queries. And then you change model configurations, you swap in models themselves, but more often it's going to be changing out the kind of prompt there and actually seeing that scoring system. So that's where everything kind of comes together, is you have evaluation frameworks that give you signal, and then you have these data sets and experiments to help you actually take a scientific approach, take a data science approach, and not just hope that what you checked is representative of everything else there.
Cool. And someone asked if you could reiterate on how to evaluate answers from Model A versus Model B at scale. And kind of like we had talked about before, that's probably going to be getting those metrics, those evaluation metrics that we define up front of how our model's performing. We have 2 of them running on the same kind of production data coming in. Maybe we even get the hallucination, is it a hallucination or not, kind of back from Arize. And then you're looking at kind of just how both of those are performing over time. Is there anything else to add to that?
Yeah, I would say like you kind of hit it on the head there, right? Like you want the evaluation framework to use LM as a judge to get you the primary signal. Then from there, you can kind of segment down that data to, maybe let's just call it 500 samples. Maybe you segment it down to 20 hallucinations. That's going to be a lot easier for me to, as a human, because ultimately you do want a human to review that. You could also do things where you might want to project those responses, those hallucinations, maybe using like a projection technique like UMAP, because they are technically, the LLM did utilize embeddings. It outputted an embedding, and then it's transformed back into text there for you to read. So you could also look for clusters. So maybe similar kind of clusters and pockets of responses and kind of think about themes. And then you might want to just keep that kind of 20 samples of hallucinations, save that off as a data set, run experiments to see if you can maybe improve it on 80%. Because at the end of the day, you're working within a non-deterministic kind of framework with LLMs at the crux of it. So there's going to have to be some relative um, kind of tolerance for things always changing and shifting and new surprises. The most important thing is that you take a statistical approach and you invest your time on improving what would be fix 50% of those samples versus like focusing on 1% of those samples to improve upon that.
Awesome. Yeah. And can you go ahead? So we're already kind of talking about this too. Can you tell us more about what, I mean, we've mentioned all these metrics and stuff. Maybe if you want to dive a little bit deeper into, all the features that Arize has, and maybe a little bit more about, we haven't mentioned the open source tool Phoenix, which I'll share a link here as well. Can you talk more about kind of the tool specifically that you're developing?
Yeah. So Phoenix, open source tool, we released that I think almost 2 years ago now. So feel free to give us a star, try it out. Overall, what it's really built for is local development, right? Like I just want to show the power and I want to show a POC using an LLM. Phoenix is great because like when you're running and even hitting chat completion on OpenAI, and then you want to run like a batch of maybe 10, 50 kind of queries, some of those might fail. And Phoenix is really great at visualizing exactly what's going on, what those error codes are. More importantly, it's also going to help you kind of start doing that early iteration. Again, all local. It's all in your machine. You can also deploy it. We actually, some of you guys, we did release a kind of stateless and hosted portion of that. But then when you kind of need that collaboration, right? Like you need to have SMEs now look at those responses. Maybe you're now thinking about how do I actually build this application entirely from more of a production lens. That's where you kind of graduate into a platform like Arize. And so what we do is we're a stateless solution that allows you to aggregate this data, perform things like online evaluations. We can automate a lot of the things that you'll write code for within Phoenix, right? Like when you're local, writing a few lines of code, that's fine. Like that's what you're here to do. Versus like when you're trying to solve bigger problems, you don't want to get that low level into code. You want to start thinking about big problems and have a very robust kind of interface to actually run experiments on data sets, kind of monitor things, visualize things at scale. Like when we do embedding analysis, that's a very expensive calculation. So a lot of local environments might not be able to take a lot of points in because it's just a lot of compute to kind of execute on, versus you're going to use like a SaaS infrastructure to kind of visualize all those points. And then the last thing I would say within our platform is we not only use AI to evaluate AI, but we also use AI to help you figure out what's going on and troubleshoot AI. So we have a co-pilot that we developed ourselves. We, of course, use our own tools during that development cycle. So we try to be informed on the actual pains that you're going to go through. And so it's going to be the traditional co-pilot interactions where you have a chatbot, but it also has all these little parts where it's like, hey, like I just threw my data in this platform, help me figure out what eval I should write. There's a little co-pilot function for that. There's prompt iteration co-pilot functions as well, like help me figure out what's wrong with this prompt and run an experiment for me. So a lot of fun things you can kind of utilize from development to production all in one platform there.
That's awesome. I love the idea of it telling you what evals you should be using, because like we said, that could be a hard thing at the beginning maybe to kind of choose. So again, going back to that summarization app that we're potentially building, and we can put that data in, and Arize Copilot can tell you, hey, we think these metrics would be useful for your app in production.
Yeah, it's crazy how specific the evals are. It's not just a very generic. It doesn't just spit out a very generic one. It really does actually ingest your data, look at it, and look at patterns. So again, like that's the strength of LLMs is kind of taking a lot of it can take in a lot of unstructured data and actually help you make sense of it. So yeah, feel free to give it a try. There is a free kind of sign up that you can kind of utilize it and try it out.
Awesome. Yeah. And I'm a huge fan of local development too, like you said, with Phoenix. I
Yeah.
know, like, I have a very powerful like M2 MacBook, and I do a lot of local iteration first before I might kick off like production GPU training job. And so, yeah, I think having that iteration is really important too. Move fast locally, and then, do more robust production kind of um, training job in my head, but there's other use cases too.
Yeah. And production means a lot of different things, and you're going to have different needs in production. So, while we have a platform for that, we also did build Phoenix to essentially work for some organizations. I work with a few large organizations that you would think would prefer and they probably would get value from a platform, but they also tried out Phoenix. They deployed it within their environment, so now it's stateless. They figured out pipelines for persistence, and they figured out their own role-based access, and all those other like quality of life and kind of important things that an enterprise platform has. And they actually use Phoenix entirely as their kind of production platform is there. So I'd say 90% of folks probably would get a lot of value out of using a traditional platform like Arize, but there are creative manners to utilize Phoenix as well.
And one of the reasons why open source is so awesome, people use
Yeah.
it in really cool ways maybe you didn't even think of at first, and then you can also write new features if you need them for your specific use case, and then that goes and helps the rest of the community and Arize, which is really cool. All right, so I guess one really last question for you is, what are you excited about right now in the AI field?
What I'm excited about is it's a little cop out, but I'm excited to just see where the trends are going. Because it's just been it's moved so fast from everyone using LangChain in the first 6 months to now there's this big split of like some folks have built and actually still use LangChain, but a lot of folks have like jumped off that train and now building their own kind of code. So it's really interesting to see this kind of divergence, if you will. And I think other parts I alluded to during this talk of like divergence and maybe experimenting with small and medium models. I think that's going to be really interesting because on top of just small and medium models, I think a lot of folks are also thinking about how do we actually utilize what we already have? Like, do we really need an LLM to do this classification, or could we use something that we already built? And so I think that all this kind of divergence is going to create a lot more like variety in how various applications are built and actually maintained. And I think eventually we're going to get to back to some sort of like alignment on best practices. But right now it's like everyone built on this like one framework of LangChain. Now we kind of split off. And I imagine in 6 months we're going to have some unification, or maybe even more divergence. But I think that's going to be the fun part to track is now the kind of genie's out of the bottle. Now there's a lot of different directions folks are going. So it'll be really interesting to see and track everything there.
Yeah, it's hard to keep up. So there's so much stuff coming out. Like every day, I feel like there's a new best model coming out or something.
Yeah, the new model, new papers. I mean, there's a podcast I listen to, and they just go through papers of highlights, and then I just try to pick and choose a few because you can't read them all. So space is moving really fast, but that's why we're here.
Awesome. Well, thank you so much for coming on. Before we wrap up the live stream, is there anything else you want to give a shout out? Any upcoming events, new features that you didn't highlight?
Yeah, I mean, we're doing a joint event together. We'll also be hosting a few events across the kind of U.S. here. So if you're in San Francisco, New York, we host a few hackathons. It's all posted on our website. But yeah, and I would say the last thing, just like if you're more academic and you're kind of looking for content to consume, we did just host and now we just published a lot of the talks that we hosted at our in-person conference that took place, I think, last month called Observe. So we could probably drop a link to it, or you can Google like Observe 2024. A lot of interesting kind of conversations from customers of ours like Wayfair or DoorDash. We also have talks from like folks that you would wonder what they're using AI for, but like there's a lot of interesting kind of talks, and it's not it's customers and a lot of like scientific and paper and research as well there.
Awesome. Everyone should go definitely check that out. I'll try to remember to include a link later in the recording here. So if you're watching this later, check the description below for any of the relevant links that for stuff that we talked about. And with that, though, I think we're going to go ahead and wrap up the live stream. So thank you, Cam, so much for making time to come on, and thank you everyone who tuned in. And I always love seeing the few comments about, like how people feel about things we talked about or questions. If you have any questions later, like if you're watching the recording or you're live and you want to come talk to us, I assume a good place is to connect with you, probably on LinkedIn, Cam, but also Arize has a pretty vibrant community Slack as well. And then also, if you have questions for me, same, feel free to connect with me on LinkedIn or join the Flight Slack.
Yeah, thanks for hosting me, and give a shout on LinkedIn or Slack. I'll be happy to chat.
Awesome. I'm going to hit the end stream button now. Sometimes there's a little pause before it wraps up. So thank you.